This is part 1 of MA 104, section 4.1. We're asked to divide using synthetic division. We can see that the polynomial we're dividing already has its terms in descending order, and it already has all of the powers of x represented. We have x to the second, then x to the first, and then our constant, which is like x to the 0. I can set up my synthetic division table by just putting the coefficients of each one of these terms up along the top. So the x squared is understood to be 1x squared, so the first number I'll put is 1. Then I have a plus 3x, so the second number will be a 3. And then I have a minus 7, so I have to make sure that I bring that negative and put the negative 7. I'm dividing by x minus 2, and when I have a polynomial that I'm dividing by, I want to put the opposite of what's with the x. So I will put a positive 2 outside the box. The procedure then is to start by bringing the first number straight down. So I'll bring that 1 straight down. Then I'll take 2 times 1, which is 2, and I'll put that product up underneath the next number, up underneath the 3. So 2 times 1 is 2. And I'll put that 2 up under the 3. Then I'll add those two numbers together. 3 plus 2 is 5. I'll do the same thing again. I'll take the 2 times 5, which is 10, and I'll put that up underneath the final number, the negative 7. And then I'll add those two numbers together. Negative 7 plus 10 is 3. These numbers that I've generated are the coefficients of my quotient. Since I started off dividing by a quadratic polynomial, in other words, an x to the second, my solution will start off 1 power less than that, so it'll start off as x to the first. So my first number was a 1, which means that I will start off with a 1x to the first, or just x, you don't have to write the 1, plus a 5, and then this last number is my remainder, so my solution has a remainder of 3. Again, we're asked to divide using synthetic division, and again, all of the powers of x are represented. I have x to the second, x to the first, and then a constant. They're also already in that descending order. So all I need now are the coefficients. So since that starts off with 4x to the second, I'll put a 4. The plus 10x means I'll put a 10, and the minus 9 means I'll put a minus 9. I am dividing by x plus 3. I need the opposite of that, which is a minus 3. And then I'll go through the same process. I'll bring the first number straight down, so I'll bring that 4 straight down. Then I multiply. Negative 3 times 4 is negative 12. That negative 12 goes up underneath the next number. And then I add again. 10 plus negative 12 is negative 2. Multiply. Negative 3 times negative 2 is positive 6, which I've put up underneath the next number. Negative 9 plus 6 is negative 3. These answers are the coefficients to my quotient. I started off with an x to the second polynomial, so I'll drop that power down to x to the first. So I have 4x to the first minus 2 with a remainder of negative 3. In this case, I'm asked to divide, but I am missing a power of x. I have an x to the third, but then it goes straight to an x to the first. I don't have an x to the second. So I have to remember that what I'm really doing here is taking 2x to the third, and then to make sure that I have that other power represented, I'll have a plus 0x to the second. I can add that coefficient of 0 in there, minus the 3x plus 1. And that's what I'll be dividing by x minus 2. You have to make sure to account for every power of x. When I set this up then, my coefficients are 2, 0, negative 3, and 1. So those go up here, 2, 0, negative 3, and 1. I'm dividing by x minus 2, so I will put a plus 2 outside the synthetic division box, and then start the process. I'll bring that 2 straight down. Multiply. 2 times 2 is 4, which goes up underneath the next number. 0 plus 4 is 4. Multiply again. I'll take 2 times 4, which is 8. Negative 3 plus 8 is 5. And finally, 2 times 5 is 10. 1 plus 10 is 11. These are the coefficients of my quotient. This one has to start, I started off with an x to the third, so my solution will start off with an x to the second. So I'll have 2x to the second, 4x to the first, 5x to the 0, or just 5. So that looks like 2x to the second plus 4x plus 5, and this time I have a remainder of 11. I'm asked in number 41, is the given number a zero of the polynomial, and to use synthetic division. Well, if negative 17 is a zero, that means that x minus negative 17 is a factor. So I can use synthetic division and the idea of zeros and factors to determine whether negative 17 is a zero of the polynomial. The way that I do this is to set up the synthetic division, which would be 1x to the second, 4x to the first, and then negative 221. And I will put the negative 17 out here. What I'm looking to see is whether or not there's a remainder. When I go through the synthetic division process, I need to see if there's a remainder in this remainder position. So as I start the process, I'll bring the 1 straight down. Negative 17 times 1 is negative 17. 4 plus negative 17 is negative 13. If I take negative 17 times negative 13, that's positive 221, which goes up underneath my next number. Negative 221 plus 221 is 0. This is the only number that I'm really interested in for this problem. 0 is the remainder of this division problem. Since 0 is a remainder, that means that x minus a negative 17 is a factor of the polynomial. Those ideas of factors and zeros are very closely related. So since x minus negative 17 is a factor because of that remainder of 0, that means that negative 17 is a zero of the polynomial. In other words, if I plug negative 17 in everywhere I see an x and simplify, I would get 0. So my answer is yes, negative 17 is a 0. And to find that out using synthetic division, I went through that process and then just looked at the remainder. The same idea applies here. I want to find out if negative 19 is a zero of the polynomial. I'll use synthetic division. I have the 2 for 2x to the third, 38 for 38x squared, negative 1 for negative 1x, and then my constant of 19. And then I'll put a negative 19 to do the division. And then I'm interested in what number I get in the remainder position. So I'll bring that 2 straight down. Negative 19 times 2 is negative 38. 38 plus negative 38 is 0. Negative 19 times 0 is 0. Negative 1 plus 0 is negative 1. Negative 19 times negative 1 is positive 19. 19 plus 19 is 38. In this case, my remainder is 38. It's not 0. That means that x minus negative 19 is not a factor of the polynomial. Another way to think about it is if I were to plug in negative 19 everywhere I see an x and simplify, my answer would be 38, not 0. Because of all of this, I can conclude that no, negative 19 is not a 0.